it's not going to be, uh, we're not going to be able to see the actual, output of that, and therefore it's not going to be, necessary for us to deal with that situation. Um, Now let's take a look at the next function here. The next format we're going to see is going to be exponential functions, right? So here we have Passport to Advanced Math questions ask you to build a function that models a given context. Exponential functions model situations in which a quantity is multiplied by a constant factor for each time period. An exponential function can be increasing with time, in which case it models exponential growth, or it can be decreasing with time, in which case it models exponential decay. And so I think the easiest way to understand the relationship here is to look at the graphical explanations, right? On the left side, we have a graph of exponential growth. On the right side, we have a graph of exponential decay. And what we really have here is looking at two different variations of the same equation. We have y equals a times 1 plus r to the power of x, and that's going to be your growth equation. And then the decay is simply saying, well, if r is negative, we'll have a decay graph. What are the different kind of variables we're dealing with? A is simply saying, what is the initial amount or the principal amount before measuring growth or decay? Basically, what are you starting with at the beginning of growth or decay? And then R is the rate at which you are either growing or decaying. You know you're growing if R is going to be greater than, if R is going to be positive, and you know you're going to be decaying if R is negative. And finally, X is saying how much time or how many time intervals have passed in order for us to get to the the overall graph. So each x kind of unit is going to be an additional time interval that has passed in this kind of overall model. And so we're going to really be tested here on how comfortable are we manipulating these questions, how comfortable are we looking at the functions being tested, and that's going to be what the core or crux of the SAT College Board test is going to focus on. Okay, so let's take a look at the first, I think, most straightforward way in which you might be tested on exponential functions on the SAT. So the first thing that we see here is that the question is giving you basically a scenario, and you're being asked to model that through an equation. Not even being asked to solve it, just how would we display this as an equation? So let's take a look. It says, a researcher estimates that the population of a city is increasing at an annual rate of 0.6%. If the current population of the city is 80,000, which of the following expressions appropriately models the population of the city t years from now, according to the researcher's estimates? We see that this is going to be an exponential growth function. We know that that's because our R of 0.6% is positive. And so we want to go back to what we know about exponential growth functions, and that is they are of the form a times 1 plus r to the power of x. So let's just kind of fill in what we know from this question. A is the starting amount of your function. What is that going to be in terms of the population of the city? It's going to be, what is the current population? And we're given that in the question as 80,000. So we get 80,000. Let me rewrite that. 80,000 as A. 1 plus, okay, what is R? Well, we know that R is our growth rate, and it's going to be given to us in the question as an annual rate of 0.6%. So what does that look like? That's 1.00, oh, sorry, not 1.0, but it's going to be 0.006. That's our rate. And finally, X. How many time intervals have passed? So in this question, it says we want to model the population of the city t years from now. And so we know that our X is going to be in terms of years, and we're going to use the variable they give us, which is t. And this is our final equation that models this entire scenario. We can say if 10 years from now, you plug in 10 for t, you'll get the population 10 years from now. 1 year from now, you plug in 1 for the population of for t, you'll get the population 1 year from now. So again, this is going to work for no matter what value of t you use. And we want to compare that to our answer choices, and we're going to get 80,000 times 1 plus 0.006 to the power of t, and that's going to be our correct answer. So notice here that they have basically all variations of this, and all of them are going to be slightly different. Looking at the different kind of answers that we would have been choosing between, we can see that we have 80,000 times 1 plus 0.006 to the power of t, where t is on the inside of the parentheses, and that's not true because we know that the appropriate setup is to have it on the outside. We have 80,000 plus 1.006 to the power of t, where it looks like we've multiplied out the parentheses, the terms almost, but again, we know that we can't do that because t needs to be remaining as multiplied. The 80,000 has to be multiplied to 1.006 to the power of t, not added. And finally, 80,000 times 0.006 to the power of t with no 1, and again, that's going to be completely wrong as well. So again, we want to, this goes back to my basically suggestion that you do the calculation without looking at the answer choices first before comparing to the answer choices, so that you aren't getting tripped up by these answer choices, which are, some of them are almost right, like B is almost right, but is actually not the correct answer. So if you have this written out equation, you're just looking for this among the options, that's going to be much easier and much more accurate when it comes to answering the questions being offered by College Board. Okay, so let's take a look at another question about exponential functions. Which of the following is equivalent to 1 over the square root of x to the power of n? So this is another exponential function dealing with the exponent here, and it's less so exponential growth or exponential decay, and more so a question of how comfortable are you manipulating an exponential function. So we want this, and we can take a look at the answer choices just to give us a hint of what the final format should like. We want x to be on top, we want it to be a numerator, and we want it to have the exponents, right? And so we want to convert this into this general format. So now let's take a look at what we can do here. So square root of x is really just x to the power of 1/2, right? So that's one thing. So we can simplify this to 1 over, or let's rewrite this. So 1 over square root of x is actually just 1 over x to the power of 1/2 to the power of n. And so that's going to be our first step when it comes to simplifying this into a correct solution. The next step is saying, okay, well, what else can we do? We can say we want this on the top. How do we do that? Well, we know that anytime we have something in the denominator position, it's really just the exponent is a -1, right? So we can multiply x times 1/2 by -1. We get x times -1/2 to the power of n. And then finally, in order to get this to a final solution where we don't have any parentheses and we are able to do this, it's testing our knowledge of what are the exponent rules. If we have a term of an exponent on the inside of parentheses raised to another power on the outside, how do we deal with that? And we know that the answer to that is just to simply multiply the two exponents. So -1/2 times n is going to be -1/2 n, and our final answer is going to be -n over 2. And so the correct answer choice here is going to be B. X equals, this term is going to be equal to x to the power of -n over 2. And that's going to be the primary function that we're looking at here. Okay, so hopefully that makes sense. And again, just testing how comfortable we are dealing with the different kind of aspects of manipulating exponential functions. Another type of question that you're going to be seeing in terms of the Passport to Advanced Math section is going to be solving rational equations. This little blurb is taken straight from College Board's website, and it says, questions on the SAT math test may assess your ability to work with rational expressions, including fractions with a variable in the denominator. This may include finding the solution to a rational equation. So an important thing to remember is, okay, well, what is a rational equation? It's simply saying any equation which has a fraction where the numerator and denominators are polynomials. And so, this is going to be, I think, something that's kind of difficult to work with at first, but once you do a few practice problems, it's not that bad. And basically, the general approach whenever you come across a rational equation is to reduce these fractions to a common denominator so that basically it's not a fraction anymore. And then you're solving the equality of the numerators by making sure all the denominators are the same. I think that's best seen through an example. We'll see here in this example problem, we have the following rational equation. 3 over 2 t plus 1 equals 2 over t plus 3 plus 1 over 4. If t is the solution to the given equation and t is greater than 0, what is the value of t? And our job here is basically to say, how do we put this in terms where it's going to be easily dealt with in terms of solving. And so what we can see here is if t plus 1 is one denominator, t plus 3 is a second denominator, and 4 is a third denominator, what is a common denominator between all three of these? It's going to be, it's going to be 4 times t plus 1 times t plus 3. If we multiply every single fraction by this term on both sides of the equation, then we would be able to solve this a lot more easily. And so that's exactly what we're going to do. So 4 times t plus 1 times t plus 3 times 3 over t plus 1 is going to give us the following. So 4 t plus 1 t plus 3, 3 times 3 over t plus 1. So what we can do here, we're going to eliminate t plus 1 here, and we get 12 times t plus 3. Okay, so that's the left side. And on the right side, we get 4 times t plus 1 times t plus 3 times 2 over t plus 3. We can eliminate t plus 3 here, and we get 8 times t plus 1. And then the last thing we have is 1/4. So 1/4 of t plus 1, 4 times t plus 1 plus t plus 3 is just going to eliminate the 4. So that would be equal to t plus 1 times t plus 3, right? And that's going to be our final solution. So put all this information together. On the left side, we had 12 t plus 3 equals 8 t plus 1 plus t plus 1 times t plus 3. Putting that together, we can solve for this, rewrite this all together. We get 12t plus 36 equals 8t plus 8 plus, let's look at t. T squared plus 4t plus 4, plus 3. Simplify this together again. We want to get this into a polynomial form, so we're going to start with t squared. We have t squared on the right side already, so t squared. And then what are all the variables with t in them? So it's going to be 12t minus 12t, so plus 0. And then we have 8 plus 3 is 11, minus 36 is equal to negative 25. All right, get that is all equal to 0. And so the final thing we get is t squared minus 25 equals 0. And then this is, again, if probably going to look familiar, it's going to be a difference of squares. And so we have t, the fully simplified is t, that looks like an e, t minus 5 times t plus 5 equals 0, right? And so our two zeros are going to be t equals 5 and t equals negative 5. Okay, so again, we've done the math. This is all going to be a little bit more just grind heavy. How comfortable are you doing the multiplication, combining the terms, eliminating terms, factoring, polynomials, etc. All the skills that we've been talking about all combined into one question. And then the final answer is if t is a solution to a given equation and t is greater than 0, we know it can't be t is equal to negative 5, so it has to be t equals 5. That's going to be the final answer, and that's what we'll plug in. Again, we see here the general solution we were talking about before is going to work. We multiply by a common term so that all the denominators are eliminated. We're just working with the numerators now. We go through that simplification and we solve it. Usually a rational equation is going to take a little bit more time, a little bit more work. That's why you will not find as many of these as, for example, a quadratic equation function, which is a lot easier to solve. But again, this is kind of combining all the skills that you need when we're talking about advanced math. And I would definitely not be surprised to see questions where you're being asked to solve rational equations. Hopefully this process made sense. Seeing y being multiplied by 4 times t plus 1 times t plus 3, because that eliminates all the denominators. Seeing the process of simplification, that's something, again, if you feel like this is somewhere you feel a little bit less confident on, you can find a lot of worksheets online for free that do rational equations. And I would just recommend going through and solving for all of them just to make sure, this is something you're comfortable doing, that you won't make errors in the middle, and that you'll be able to solve that on the actual testing. Okay. Let's take a look at the next question. So there is a category of questions in advanced math, which is going to seem a little bit out of place, and it's a system of equations. And the reason it's here is because while most of the linear equations that you're going to see on the SAT are going to be, most of the systems of equations you're going to see on the SAT are going to be linear equations, like we talked about in the Heart of Algebra section last week. There are going to be questions in which you're asked to solve a system of equations where one equation is linear and the other one is a quadratic or nonlinear equation. So that's going to be a little bit less straightforward than what we would do with a linear system of equations with our substitution and elimination, but those strategies are going to still make sense, right? We can see this most clearly when we're talking in this example here. And so remember, as a refresher, when we're talking about systems of equations in the linear format, we talked about it in terms of the context of there being 3 possible ways to solve it. You could, number 1, substitute, put one variable in terms of the other variable and plug that into the second equation. You could eliminate, which is saying, how do we get rid of one of the variables by adding or subtracting our 2 equations? And you could graph and say, where do our systems of equations intersect? And so it's going to be hard to do elimination, I believe, with the format of one of your equations as a polynomial, but it is still very possible to do substitution. And so we can see here that 3x plus y equals -3, that's our linear equation. It's fairly simple to isolate y, right? We just subtract 3x from both sides. We're going to get y equals -3x minus 3, right? We can plug that into our second equation, and we're going to get the following: x plus 1 squared minus 4, x plus 1 minus 6 equals -3x minus 3, right? And so we can think of this as almost in terms of a quadratic equation, right? X plus 1 is squared here. X plus 1 is a single coefficient here, a single exponent here, I'm sorry, and then 6 has no coefficient. So we could almost treat x plus 1 as its own kind of variable where we don't mess with the x plus 1, we don't multiply it all out. Is it possible for us to multiply all of this out and then plug it all together and come up with our exponents? Definitely. But in this scenario, it actually might be beneficial for us to see, can we get this into a format where it's not going to be necessary for us to mess with the x plus 1 format. So let's keep x plus 1 squared for now. Say x plus 1 squared. And then we have 3x here, so we know we're going to have to change something here. So we can multiply this out. So we have -4x minus 4 minus 6 equals -3x minus 3. We get x plus 1 squared minus 4x plus 3x is going to equal to minus x. Minus 4 minus 6 is -10. Plus 3 is going to be -7. And that's going to be equal to 0 because we've eliminated everything on the right side. And then we can try and get this into a situation in which we have x minus 1 as the middle variable. And we can do that. We can do x plus 1 squared And this is going to be kind of our grouping. And we're going to say negative x plus 1, right? So that's going to be negative 1. And sorry, not 1. Yeah, wait, yes, plus 1. And then we'll be left with, because we put 1 in here, we still have negative 6 on the outside. And so we have this equation where x plus 1 is our variable of choice. It's x plus 1 squared minus x plus 1 minus 6. And we are going to be able to factor that in order to get this into a more simple form. We're going to do the same thing we did last time. So first coefficient, what is a? A is 1, so it's just 1 and 1. And we know we want the coefficients of c are equal to, when added together, are equal to negative 1. So whatever coefficients of c when added together equals to negative 1, we can do the following. 1 times negative 3 is negative 3, 1 times 2 is 2, negative 3 plus 2 is negative 1, and that's going to be checked out for what we want here. So we would get the following. We would have first x plus 1 plus 2 times x plus 1 minus 3 equals 0. And that's going to give us a final form of x plus 3 times x minus 2 equals 0. Right? Putting that together, we can get a solution where x is either equal to 2 or x is equal to negative 3. Putting this aside, we've solved this equation. Our last step is to plug in and get our y value, because the question is asking us to find y. So we can do 2 is y is equal to, it would be 3 times 2 plus y equals negative 3. That's going to give us y equals negative 9. And the other way we can do it is plugging in negative 3. We get 3 times negative 3 plus y equals negative 3. That's negative 9 plus both sides y equals 6, right? Information given to us is that y is greater than 0. We know that y equals negative 9 is not going to work. That means y equals 6 is going to be our final answer, and that is what we will end up plugging in. That's a missing box. There we go. Y equals 6 is going to be our final answer. Hopefully we see here that this process, systems of equations is just a little bit more complex because we're dealing with a nonlinear second equation, but the substitution method still works. And if we wanted to graph this, right, if we graphed all this into the graphing calculator, we would also see the 2 points that we identified, 2, 9, and negative 3, 6, are both going to be our intersections between the graphs, right? So it'd be like something like this. Right, with these two intersection points, right? Looking at the information we have, hopefully it made sense why we kept x plus 1 in the exponents. In the parentheses, we didn't multiply it out. We kind of grouped it so that we could keep it that way, and that would make the calculation a little bit more simple. Again, is that necessary? No. You could do a full simplification. You could do x squared plus 2x plus 1, and then simplify and put in negative x minus 7. You would still be able to do a factoring, still get the right answer. It'd just be an extra step that you would have had to take. So whatever was going to be the quickest for you is the method I would suggest. But hopefully this process that we went through makes sense. Okay. Another category of questions that we're going to be looking at on the SAT is going to be graphical representations of functions. So looking at this little blurb that comes from College Board, we see a function f has a graph in the xy plane, which is the graph of the equation y equals f of x, or equivalently consists of all ordered pairs x comma f of x. Some Passport to Advanced Math questions are going to assess your ability to relate properties of the function f to properties of its graph and vice versa. You may be required to apply some of the following relationships. And those relationships listed out are intercepts, domain and range, maximum and minimum values, increasing and decreasing behavior, end behavior, and transformations. And so basically saying, can you interpret the graph when you asked about a function relative to its graph? Do you know how to the different qualities that you might be asked to look for? We can go into a little bit more detail about what exactly each of these bullet points is going to mean. The first bullet point is intercepts. And so, we have either y-intercepts or x-intercepts. We can start with the x-intercept. It's essentially saying which values of x are there where f of x is equal to 0, or if we were to graph it out, which points on the graph do the function intersect the x-axis. So if you graph it out and your function never touches the x-axis, then you have no x-intercepts. And so that's, x-intercepts are what we're really solving for when we're doing things like factoring quadratics and finding the solution to polynomials, right? Those are the x-intercepts. The y-intercept is saying which y coordinate on the graph, or which value of f corresponds to the value where x is equal to 0, right? So where the graph intersects the vertical y-axis. And so, if there is no point in which the x equals 0 is in the domain for your function, then that means you have no y-intercept, right? So intercepts, that's fairly standard stuff. Basically, x-intercept is intersecting the y-axis, x-axis, and y-intercept is intersecting the y-axis, right? So those are our two things for intercepts. Domain and range are basically sets of possible values for where your function is defined. Defined means that there's a value. It's not like divided by 0, or it's not like does not exist. The range refers to y, right? And so that is saying y equals f of x for all these possible values. So you might say the y can range anywhere between 0 and 100, or negative infinity to positive infinity. And then you have your domain, which is essentially just a range for x values, and saying, which set of coordinates includes all the points in which you could plug into your function and not have it not exist, right? And so that's going to be the domain and range portions of your graph. Maximum and minimum values are saying, is there a point in time in which your function peaks and then there's no other point in time which it surpasses that value? That's your maximum. And your minimum value is saying, is there any point in time in which you have a low point and you never again reach that low point? I think maximum and minimum values can be best symbolized by parabolas. So a maximum value would be a negative parabola. This is your maximum point, right here. You're never going to have the inverse parabola exceed this vertex point right here. Similarly, if you want to have a minimum value, you can have a positive parabola. You're never going to have a value of this positive parabola that's less than this vertex point, and so that's going to be a minimum value. So that's kind of two ways we can interpret the different things we're doing there. Increasing and decreasing behavior is basically saying the graph, and it can show, there are portions of your graph in which your function is increasing, there are portions of your function in which it's decreasing. Again, we can do a parabola, an inverse parabola. Let's try to draw that better. Yeah, that's my best job. Basically saying, from negative infinity to 0, if we say 0 is a vertex, negative infinity to 0, your graph is increasing. From 0 to infinity, it's decreasing, right? So that's kind of how you can separate your graph into those two types of behavior. End behavior says you can have a graph of f where the function is increasing or decreasing without limits, as x increases or decreases without limits. So for example, as x increases here, the end behavior of this graph is going to be negative infinity on this side. And similarly here, as x decreases without limit, the end behavior of this graph is going to be negative infinity on this side, because there's no kind of cap to how low these values can go. And then the final thing that's important to realize is transformations. And so how can you change the equation of a graph so that it shifts on the graph when you plug it into your calculator? The most common two types of transformations are either going to be a vertical shift or a horizontal shift. A vertical shift is simply saying if you just add a constant a to your total equation, then you'll see a vertical shift of units. So if you have x squared as your original equation, and then you add a, then it would go from something like this to something like this, right? That's going to be a vertical transformation where there's that increase by a, right? If you want a horizontal shift, it's a little bit more complicated. You're going to increase by a, but you increase it within the parentheses of the function. So instead of saying x squared, if you want to say, I want to shift this to the right by 1, then you can say x minus 1 squared, and that's going to have, instead of having it here, you're going to have it over there. Or let me see if I can draw that a little bit more clearly. I'm going to have it over there, right? So you, instead of having a vertex here, a vertex at x equals 1. And so that's the horizontal transformation. And so depending on which one you're doing, that's going to depend on what kind of modification you're making to the total graph. Okay, so that kind of covers the types of questions you're going to see popping up in terms of graphs. And so we can take a look at ways in which you might be tested in actual questions. So the graph of which of the following functions in the xy plane has x-intercepts at -4 and 5, really just testing, do you know the relationship between x-intercepts and zeros? And so if you do, then you know that any x-intercept is a solution to the equation. X-intercept means that y is equal to 0, and that's what we define as a solution. And so what we're really going to have is the same thing we would have done if we were given, something like this, right? Like if this was, if we did our factoring and we were given different variables in which our parabola or our quadratic would solve to. If it has x-intercepts at -4, then we know it's going to be something like x minus -4 and x minus 5, right? So it's going to be x plus 4 times x minus 5. X plus 4 times x minus 5. That's going to be our graph of the function, our equation of the function, which has x-intercepts at -4 and 5. And so that's going to be answer choice A, right? Hopefully that makes sense, that you see this relationship between the x-intercepts and the zeros, and that's going to be a pretty straightforward question if you know that relationship. Okay, the next thing that we're going to be tested on is knowledge of kind of a systems of equations in the context of a graph. So here we have a function equal to x to the power of 4 minus 2.4x squared, where y equals f of x as shown above. If k is a constant such that the equation f of x equals k has 4 solutions, which of the following could be the value of k? The important thing to remember here is that this is really a systems of equations where you're graphing two graphs. One of them is a polynomial, the other one is a linear equation, specifically a horizontal constant. And so if we remember from the Heart of Algebra section that the solutions to a system of equations in the graph are simply wherever the two lines intersect, then we would basically be asked in this question, if we were to rephrase it as, which of the following could be the value of k such that the line k, or y equals k, intersects this graph 4 times. And so looking at the answer choices, it becomes pretty clear which one of those is the case. If we have a is equal to 1, the intersection is only going to be for, the intersection is only going to be for 2 points, right? It's going to be here and here. You have 2 points. If it's at 0, we'll have 3 points. 1, 2, 3. If it's at -1, we'll have 1, 2, 3, 4. And if it's at -2, we'll have 0, right? Like -2 is not going to even intersect. So the only point in time in which our line for y equals k intersects this graph 4 times at 4 unique points is going to be at y equals -1, with one intersection here, one intersection here, one intersection here, and one intersection here. And that's going to be the correct answer here, because we know that there's this graphical interpretation where the solutions, having 4 solutions means intersecting 4 4 times. And so we want to keep an eye on that. Okay. The next concept we can talk about after graphs is going to be function notation. So this little blurb, again taken from College Board, is going to say, the SAT math test assesses your understanding of function notation. You must be able to evaluate a function given the rule that defines it. And if the function describes a context, you may need to interpret the value of the function in the context, right? And so things to keep in mind here are the definition of a function. A function cannot have multiple y solutions. Can have multiple solutions for a single input or x. So that's the vertical line test, right? Saying like you can't have a function where you can draw a vertical line and intersect it multiple times. So a sideways parabola is not a function because I can draw this this vertical line and have 2 solutions, one here and one here, for only one x input. And so that's going to be one definition. And there's going to be other kind of tests of how to put it into a proper notation and what we might expect from basically College Board saying, do you know what a function is and how to mess around with that. So this is going to be one of those composite function questions where it's saying, do you know how to deal with multiple functions with the output of one function being the input to another function? So we can do this several ways. The first way is saying, let's composite this function so that we just get a single function. If we know that we want f of x to be our overall function, then we can really just substitute 2x plus 1 into the f of x equation. So f of x starts with 2x, it starts with g of x plus 4. We can say, let's substitute 2x plus 1 in for g of x. We get 2x plus 1 plus 4. We get 2x plus 5. And then we can say, oh, well, we only have, it's just a linear equation. If we have f of 2, then we say, well, f of 2 means x is equal to 2. That means the following would be true. 2 times 2 plus 5 equals 9, and that's our solution. And that would be the right answer. That's one way you could do it. That's if you want to make a function that is going to work for all values of f, not just 2. Another solution you can say is I'll start with 2 and work my way into the other equation. So if f of x equals g of x, that means f of 2 is equal to g of 2 plus 4. What is g of 2 equal to? So g of x is equal to 2x plus 1. That means g of 2 is equal to 2 times 2 plus 1, so 5. I'm going to take the output from this back into the original. So f of 2 is equal to 5 plus 4 equals 9. And so we get 9 on both ways. So again, both ways are going to work. Whichever one's faster for you is going to work. This is, I think, this method of compositing the functions yourself is going to give you a more, universally applicable function for you to use. You can use 2x plus 5. You can use that for any. If it changes to 5, you'd still get 15. If it changes to 0, you'd still get 5, right? So you can apply that rather than having to go back into the g of x and then bring that into the f of x. That's a little bit more complicated. So again, up to you how you want to approach that problem. And then the last category is just going to be something that the SAT refers to as complex equations in context. Again, the blurb that describes this says that Passport to Advanced Math questions may ask you to identify connections between the function, its graph, and the context it describes. You may be asked to use an equation describing a context to determine how a change in one quantity affects another quantity. You may also be asked to manipulate an equation to isolate a quantity of interest on one side of the equation. You may be asked to produce or identify a form of an equation that reveals new information about the context it represents or about the graphical representation of the equation. So again, I think this is just kind of the catch-all that they're saying about a broad category of questions that are really just about interpretation of data or interpretation of functions in different real life scenarios. This is a focus that College Board has taken a little bit more recently when designing their test questions. So basically saying, can you use the math and also use the math to describe real world things, right? And we're going to take a look at, what does this kind of abstract category of questions look like? So this question here says, for a certain reservoir, the function f gives the water level f of n to the nearest whole percent of capacity on the nth day of 2016. Which of the following is the best interpretation of f of 37 equals 70? So we're not given the equation, right? This is not a math question in terms of solving for anything. What we are given is a relationship of what this function is supposed to describe. So if we know that the function gives water level, then it means that if we want to interpret, it says that on the nth day, if n equals 37, then on the 37th day, the water level is at 70%, or sorry, the water level of the reservoir is at 70% capacity. And so that's how we would interpret it without looking at, I haven't looked at any of the answer choices right now, right? And so we now have having this kind of framework for what the answer choice is going to look like. We want to look for the answer choice that best matches our interpretation. So that's going to be, reading through the question choices, answer C. On the 37th day of 2016, the water level of the reservoir was at 70% capacity. We didn't pick A and B because A put 37 as a percentage, which is not correct because 37 is the day it is. B puts, says that, this is a prediction that is consistent across not just the 37th day, but the first 36 days leading up to it as well. And we know that, this function is just only applicable to the one day. And D is going to be wrong because it says the 70th day rather than the 37th day. So it's switched to two numbers. So C is going to be the right answer here. So again, we're just being asked to really interpret the amount of the data that we have here to do the testing. The next question says, if an object of mass m is moving at speed v, the object's kinetic energy, or Ke, is given by the equation Ke equals 1/2 mv squared. If the mass of the object is halved and its speed is doubled, how does the kinetic energy change? And so this is saying, can we modify this equation given the context that it is a physics equation, right? So you don't have to have any knowledge of physics for this question. It's not important. It's just how do we modify this equation to adjust for the changes. So we start with Ke oops. Let's see if we can get that. Okay, all right. One more time. Ke equals 1/2 mv squared. The mass of the object is halved, so that means m is divided by 2, so we get 1/2 m over 2. And then its speed is doubled, which means velocity here, v, is doubled, so that's 2v. How does the kinetic energy change? So how does this change into this, right? So we'll call this Ke1. Putting this together, we get m over 4 times 4v. So we just get v squared, mv squared. The difference between mv squared and 1/2 is that mv squared is 2 times the value of 1/2 mv squared, because this is 1/2 and this has no 1/2. So what we can interpret this as is that the kinetic energy is doubled when you do a halving of the mass and a doubling of the speed. And so we're going to look for some answer choice that kind of validates that conclusion, and that's going to be answer choice C. The kinetic energy is doubled, and that's what we're going to deal with and choose as the correct answer here. So again, we did not have to have any knowledge of physics. We just needed to be able to interpret the information given to us and say, how do I apply this to the math concepts I'm already comfortable with, right? Okay, taking a look at another question. It says, a gas in a container will escape through holes of microscopic size as long as the holes are larger than the gas molecules. This process is called effusion. If a gas of molar mass M1 effuses at a rate of R1 and a gas of molar mass M2 effuses at a rate of R2, then the following relationships holds. R1 over R2 is equal to the square root of M2 over M1. This is known as Graham's law. Which of the following correctly expresses M2 in terms of N1, R1, and R2? So we're given a lot of information here. You don't need to have a chemistry background for this. You don't need to have a physics background for this. And what we can really see is the part which we care about, which of the following correctly expresses M2 in terms of M1, R1, and R2. We can do that without having any knowledge. Like we can cross all the stuff that to talk about here. We don't even have to know this is Graham's law. The only thing we have to know is this equation and say we're being asked to find M2. You don't have to know the law of diffusion. You don't have to know what it's called. You don't have to know the background of this question. If we were simply given this equation and said which of the following correctly expresses M2 in terms of the other variables, we would be able to solve that perfectly fine. So don't get lost or caught up in the kind of extra information you're giving you here. That's just kind of to distract you. You just have to do the algebraic solving that lets you get M2 here. So how do we do this? First thing we're going to do is going to square both sides, right? We want to get M2 out of the radical. So we're going to get R1 squared for R2 squared is equal to M2 over M1. And the last thing we would do is just multiply M1 on both sides. So we get M2 equals M1 times R1 squared over R2 squared, right? And we want to match that up with one of the answer choices, taking a look at the answer choices where we're given. We're going to go answer choice A. M2 equals M1 times R1 squared divided by R2 squared. Again, the key kind of, I think, takeaway from this question is, don't see a giant block of text and be like, oh, I don't know anything about chemistry. I don't know anything about physics. I don't know about the law of diffusion or Graham's law. None of that matters for this question. Focus on what matters. You're just kind of shuffling the variables around in this equation, and that's not going to be something that's going to be super challenging for you versus kind of trying to understand, oh, what does R represent? What does M2 represent? It doesn't matter. They're just variables, right? So you just have to focus on the end goal here. Okay, great. Let's take a look at the next question. And so this question here says, a store manager estimates that if a video game is sold at a price of $P, a store will have weekly revenue in dollars of RP equals negative 4P squared plus 200P from the sale of the video games. Which of the following equivalent forms of RP shows as constants or coefficients the maximum possible weekly revenue and the price that results in the maximum revenue? And so when we look at this question, it says we want to find the maximum possible weekly revenue and we want to know the price that results in the maximum revenue. That's just the vertex of this parabola, right? We're given a negative parabola and saying, if we graphed it, it would look something like this, right? It would look something like that. There's a peak here, there's a vertex right here, and that's going to be the maximum possible weekly revenue is the y point, and the price that results in that maximum revenue, that's going to be this x point, right? So it's basically saying find the vertex of this parabola. And so what we can do here is think about the equation we know that allows us to find the vertex. So we see the vertex as h and k. Then we know that in order to find where h is the x exponent for the vertex and k is the y exponent, then we know that we can use the equation h equals negative b over 2a to find h here, and that's going to be in our equation equal to negative 200 divided by 2 times negative 4, which is negative 8. And that's going to give us 25. And then k is just simply going to be f of h, right? So for us, that's negative 4 times 25 squared plus 200 times 25. And that's going to be equal to, if we plug that into our calculators, roughly 2,500. Not roughly, exactly 2,500, right? So keeping all that in mind, we now have our vertex is equal to 25, comma 2,500, right? Now we're not being asked to find the vertex specifically, but rather which of the following equivalent forms shows as constants or coefficients the vertex. So we know that there's a vertex form that we could place our equation into, which is y equals a times x minus h squared plus k. And for us to put that in, we would do y equals a x minus 25 squared plus 2500. And we see that matches up very well with answer choice D, where a is equal to -4. We have x is p minus 25 squared plus 2500. This is going to be our equation in vertex form, where 25 comma 2500 is going to represent the price that results in the maximum revenue and the maximum possible weekly revenue in that form. So D is the right answer here. And again, the important thing to take away is this is something that you're not going to be tested on too often, but knowing this way of calculating the x value for your vertex, h equals negative b over 2a, is going to be really important for solving the rest of this problem. If you didn't know this, it's going to be really hard. You might have to graph it. You might have to plug in points. And so this was the critical piece of information here. So we want to make sure that you are comfortable working with that, and we know that that's something that we can do with the rest of our kind of problems. And so that kind of wraps up the different things we talked about today. We went through polynomials and rewriting expressions, talking about how to manipulate the standard polynomials, add, subtract, multiply, right? The next thing we talked about was quadratics and saying, what are the different methods for grouping together the sum product pattern? What are different ways we can use quadratic functions? What are all the different ways we can solve essentially a quadratic? And then we talked about exponential functions and the standard format for them, either a growth function or a decay function, and being able to visualize that. We talked about solving rational equations. How do we get the denominator out? How do we put this all in terms of kind of the algebraic expressions that we're used to solving? We talked about systems of equations where one of your equation is quadratic or nonlinear. That's going to be the following, where we have that kind of substitution approach still being applicable. We have graphical representations of functions going into the relationship between zeros and the equation, the systems of equations, graphical solutions, and then function notation, talking about composite functions. And finally, complex equations and context. Basically, how do you apply math to real-world scenarios, whether it be physics or chemistry or revenue in a business? Again, these are not necessary. You don't have to know anything about any of these fields, any about these scenarios. All you have to know is how do you kind of take away the key pieces of information and apply the kind of math that you're very comfortable with to those scenarios. The last thing I'm going to talk about today is just going to be test-taking strategy. This is for those of you who might be struggling not with understanding the concepts or being comfortable with the skills, but just having enough time to get to all the questions. I think that's a very common struggle. The time it takes to complete an SAT is one of the things that makes it hard. Given the infinite amount of time, it's very likely that a lot of you guys would be doing very, very well. And so for those of you who say, I feel like I've improved my skills as much as possible. I need a way to kind of organize my time when it comes to taking the test. I would suggest the following strategy. It's called a two-pass strategy. The first one is basically saying, or the strategy is basically saying you go through the test twice. And some of you guys might already be doing this, but it's good to kind of organize your strategy or approach to a test before you walk in, right? And have like a conscious framework of how you're going to tackle the different questions. So your first pass is you're picking the lowest hanging fruit. And it's basically saying you're reading each question, you're saying, do I know how to do this, and can I do it pretty quickly and confidently, or is this something I'm not really sure how to start? If you can do it fairly quickly and you're confident in your ability to solve it, then do it right then on that first pass, right? You don't want to spend too much time on any of these questions, no more than a minute. If it's taking a lot longer, you can feel free to move on and come back and finish the work. But you want to basically make sure that you finish going through the entire test at least once with time left over to go back. And so by the time you finish that first pass, you should be done with all the questions you feel fairly confident on, and the remaining questions are ones that are a little bit more challenging, that you are less confident on, and are going to take a little bit more time. So pass two is saying, let me tackle the questions that I think I have the highest chance of getting in the remaining amount of time I have left. So you want to start with the easiest questions, the ones maybe you've already finished half the work, or the ones you knew how to do it, but you just didn't think you wanted to spend the time right then, but you know how to approach the problem. Those are the ones you want to do first, and you want to leave the ones where you're just like, I have absolutely no idea how to do this problem. You want to leave those for last. And so that's going to reward you in terms of saying, when we go to grading, an easy question is worth exactly the same amount of points as a hard question. So why spend all of your time on a hard question and get the easy questions wrong because you couldn't get to them and you had to guess? That is going to unfairly or inefficiently lower your score when you could be getting a lot more points by doing the questions you are very confident in your ability in. And then the second thing is, the way that you're doing this and organizing your thoughts. If you have that strategy in mind, then it's going to make it a lot easier for you to get a good feel of all the different questions you're being asked, especially on practice tests, rather than having to, spend guess on the last 10 questions, for example, without ever having a chance to read them and know whether or not you're going to be able to answer those questions. And finally, guessing for structure. Guessing and structure, I think these are very specific tips. These are not going to be the tips that are going to increase your score by a lot, but structurally speaking, when you have that division between multiple choice and grading questions, generally speaking, your grading questions might be harder because you have less answer choice. You can't choose between answer choices, but the first few grading questions on every test are going to be fairly easy. That's just by design, and they kind of they work your way to getting to the more difficult grading questions. So if you're stuck on questions and you have both grading questions that you haven't tried yet and the last few multiple choice questions, which are typically harder, it might be better to spend some time doing the first few grading problems, because even without answer choices, oftentimes those are going to be easier to answer. And then the final suggestion I have is just guessing. There's no penalty for guessing on the SAT. There's no reason for you to leave a question blank. Pick a letter, guess that letter for all the answers that you aren't able to get to, and that's possibly going to be how you're going to get a few more points as well, right? So all these strategies are just trying to maximize your ability to get a good score on the SAT. So hopefully today's session was helpful. I think we covered all the major things you can expect to cover or see on the official SAT. In terms of the advanced math material. Again, anything that you feel like you have trouble with, that you're struggling with, my suggestion goes back to just practice, become comfortable with those questions. The more you're, putting pen to paper and doing those, the easier it is going to be for you to apply those concepts on test day. Other than that, that's all we have for today. Hope you guys enjoy the rest of your weekend, and I hope everybody's staying safe. If you want to book individual sessions, there's always an option for doing that, but we'll be continuing to do lessons like these throughout the next few weeks. Have a good one, guys, and take care.